Okay, looks good. Hi, everyone, also on YouTube.
We are live.
And we are still waiting until 5 p.m. to get started. Let me just mute my, yeah, I think it works. Everything looks good. Just double check YouTube.
Yeah, we have some people watching already, so that's good.
Hi, everyone. I will just also try if it's possible to link to our Discord server, also directly in the YouTube chat. So if you want to ask questions, please do so via our Discord. That's the easiest way. And then we will ask them live to our speakers today. Just grab the invite.
Cool. Cool. So is everyone talking from Europe? Denis, János?
Yeah.
Yep.
Cool. So we are all in the, well, I guess in this, well, I know that János is in Vienna. Denis?
Yeah, I'm close to Paris, so same time zone.
Perfect. So it's all 5 to everyone.
Yeah.
Cool.
That's the interesting part with all these virtual meetups, that people are joining from all over. In the afternoon, I did a meetup for Cloud Native group in Jakarta in Indonesia. And they were actually, also they had people from all the different regions joining. So Denis, you heard my talk last week?
Yeah.
So it's, and I did more or less the same today for the Jakarta community. And we're also using StreamYard, so very similar setup. And they had quite a couple of questions directly from YouTube coming in. So if there are any questions, I will also watch the YouTube comments when they're coming. I will ask them. I will ask them to you later, or I will just with StreamYard. It's pretty easy to directly show them to the speaker. So yeah.
Yeah, so it's funny because lots of remote conferences happening and made everything a little easier, because now you don't have to travel to places, and it's become acceptable to speak at a conference which is halfway around the world, and also as a visitor. So when you're like traveling to conferences and buying conference tickets was quite expensive. So now I'm actually quite glad that most conferences have gone online and have a reasonable price, because I mean, traveling to conference could easily run you up to more than €1,000 when you're going somewhere.
Yeah, sometimes just to pay the ticket, in fact.
Yeah, ticket is like 600, and then the flight and the hotel and everything. So that's it's you could say it's the new normal, and it's really hard for some people. But I think like the inner nerd who just likes to sit at home in a hoodie is very thankful to what happened, even though it's not. I mean, it's not without controversy to say that.
But for the meetup, we really miss the discussions after the talks. That's what we really miss, and it's very difficult to replace that.
Yeah, I guess we could, like, everybody could just hang out on the Discord and we can have a chat afterwards, but it's definitely the bring your own beer kind of event.
Yeah.
I definitely miss the part afterwards. Well, should we start?
Yes.
Yeah.
By all means.
A lot of folks joining on YouTube, and please, cool. Julian, I hand over.
Awesome. So, hello everyone. Thanks for joining the second event of Cloud Native ComputingLinz meetup. So I'll just go over some topics that we have at the beginning, and then I'll pass to the presenters of today. So if you are on Twitter, please follow us, CloudNativeLinz, and if you are watching, just if you would like to comment and then everything, just tag us and help us to promote the group. And you can also join the community.cncf.io/links. We are part of the CNCF community group. And yeah, that's it. So before starting, here's the agenda. So I'm starting with the welcome message. Then we will start with Denis Jannot from Solo.io. And then at around 6, we pass by to János Pásztor. Well, we just found out that he's joining Red Hat soon, so that's really nice. And then we finish with closing remarks, and at 7 we are coming to an end. Of course, that's not strict, and we can go a little bit over or shorter in sometimes. Then we follow the Berlin Code of Conduct. If you would like to know more about it, you can take a look into berlincodeofconduct.org. But mainly, we welcome everyone, and it doesn't matter the gender or the skills level or whatever, everyone is welcome in our community. And mainly be kind with everyone, respect. Of course, we cannot remove you from watching YouTube, but please behave on the comments and everything, because, well, we try to make it welcoming to everyone. So, yeah, basically be kind. The event is organized by myself and Jürgen. I'm a software engineer at Dynatrace. Here's my Twitter handle if you would like to get in touch with us. In the page of the CNCF meetup, you can also register for a talk and to sponsor our event. I'll tell about that in a second. But if you want to get in touch directly with us, here are our Twitter handles. Jürgen, do you want to say something?
Just say hi, everyone. I'm Jürgen. Here's also my Twitter handle if you want to follow. And if you want to get in touch around any open source technologies, that's what's really drives my work mostly. I'd love to get in touch with you. And yeah, that's it.
So I would like to thank Dynatrace for sponsoring this streaming. So we are using a paid streaming platform, and if you would like to stream if you would like to sponsor one of our next streamings, please get in touch with us, and we can mention your company, your brand, and you will help the community and us to have a better streaming experience. Well, as I mentioned, if you would like to talk at one of our events, you can reach out to us in the tinyurl.com/CNCLinz-talk, or if you would like to sponsor one, the same CNCLinz-sponsor. You have a form and you can fill out the information about the talk or about the sponsor, and we will get in touch with you. That's a new part of our community group where we share some community news. And here we have some workshops on the cloud native technologies powered by Microsoft Austria. And if you would like, I think Jürgen will paste this link in the YouTube channel afterwards, so you can take a look into those workshops. And if you have something to share and you are part of our community, we'll be happy to share with everyone as well. So get in touch with us. If you want to continue the discussion and raise questions during the presentation and everything, of course, we are following the YouTube channel as well, so you can post your questions over there. But if you would like to continue the discussion afterwards and keep engaged with the community, join us on our CNCLinz Discord channel. And that's something that we are trying to have to replace the talks that we have after the meetups. So we were mentioning before that that's something that we miss from the in-person meetups. So yeah, Discord is the workaround that we have. And finally, so today's speakers, we are starting with Denis. He's a director of sales engineer in EMEA at Solo.io, and he'll talk a little bit more about what he do, and yeah. And afterwards we have, and after that at 6 we have János. He's at the moment a lecturer at FH Campus Wien. I don't know if he will continue with that. And
yeah,
so yeah, perfect. So yeah, I'll let them introduce themselves because, well, yeah, I think they can do that better than me. Welcome everyone, and yeah, thanks. Denis, the stage is all yours.
Let me share my screen.
Perfect. And I just want to add, if there are any questions, please ask them early, ask them on Discord or on YouTube, because Denis has to leave quite on time for another presentation he has to do. So thanks for being with us, and we hope we can still have a great presentation and hopefully a little bit of Q&A afterwards. So I will give you the screen, and thanks so much.
Can you see my screen?
Yeah.
Good, thanks. So thanks for the introduction. So yeah, I am, like you said, working at Solo.io and being a director of sales engineering covering like EMEA. And you have like some of my details here if you want to contact me. But the idea of this talk is really to go through the common challenges that people face when they try to expose services to the outside world, or when they want to improve the way they handle service-to-service communications. So I'll go through a little bit of these challenges at the beginning, and then I'll introduce some of the projects we are working on at Solo.io. So obviously, you've seen a lot of slides like that where we speak about going from Monolith to microservices, but I mean, in this talk, what I'm going to do is like more from Monolith to service mesh and trying to look at all the things in the middle. So people go from Monolith to microservices because they want to be able to release different components of the application independently, and they want to scale them differently and so on. And I would say that another thing that is happening or has happened, or whatever the way you want to say that, but definitely when people develop new application today, they tend to deploy these microservices on Kubernetes. And then when they start to have these microservices on Kubernetes, one of the first things they need to think about is how I can expose these services to the outside world. And obviously, the easiest way to do that is to use an Ingress controller, like based on Nginx or Traffic or any other solution available, depending on where you deploy your Kubernetes cluster. So you can then define these Ingress objects to expose your apps to the outside world. And you have a few options there, like you can define which certificate you want to use if you want to expose them with HTTPS. You can have some basic routing capability, but it's very quickly limited. And when you start to need more capabilities, and especially because a lot of people, when they write new application, they don't want to like handle like the authentication on each application separately. They don't want to, some of them, they want to like write their application and expose them with gRPC instead of HTTP. So all of these scenarios, you basically cannot really handle that with an Ingress controller easily. So in this case, people tend to use an API gateway. And the API gateway can handle like the authentication for the application. You can like configure like OIDC that happens on the API gateway, and then the authentication provider will return like a JWT token, and the API gateway can extract some information from that, add some new headers, so that when the backend service receives the request, it knows which user has been authenticated, for example. But you can do much more. You can expose your gRPC service as an HTTP application, and it also allows you to expose applications that are not running on Kubernetes, so that you can expose some application running, for example, on VMware, some other application that are just like Lambda functions on AWS, and so on. So that's really the benefits you get when you use like a true API gateway versus like an Ingress controller. And then when you have secured the edge, then the next step is, how do I get smarter ways of for service-to-service communication? How I can secure this communication, how I can get more insight about what's going on. And basically the requirements, there are many requirements, but the most important ones are the ones that I've listed here. So you need to manage identity, so that when a request comes from one service to another, then the targeted service knows who is the service that requests this information. You want to handle encryption between these services. You want to manage certificates, especially the rotating certificate is not something easy to do. You want to be able to manage the way the traffic is handled. You want to manage access control. You want to get insight about, I don't know, like what are the number of errors when this microservice talk to this other microservice, for example. So a lot of different requirements. If you just use the traditional Kubernetes approach, where you expose the targeted microservice with a Kubernetes service, then you don't get much. I mean, you can obviously use labels so that you can do a little bit of traffic management that way. You have a little bit of health check capabilities there as well. But for example, if you want to encrypt the traffic, then it has to be done at the application level. So the application has to agree that the source microservice has to agree with the target microservice to on the way they will encrypt the communication together. And you need a lot of third-party software on top of your Kubernetes cluster, like some for access control, some for like identity management, some for managing certificates, and so on. So you don't get much by just using the traditional approach on Kubernetes. Another way is to use like an API gateway, and that's what has been done for some time. I mean, it has been quite common to have communication between microservices going through an API gateway, and it solves a lot of the problems that I described before, a lot of the challenges. You can manage access control that way. You can transform your request. You can get insight about what's going on. But you still need to manage the encryption at the application level, and you don't have everything that I listed before. But the biggest issue with this approach, and okay, that's the first time I get that on Google Slides. That's okay. Should be okay if I present again. Oh, okay, it doesn't like this slide. Anyway, I'll just use this presenter mode here. So the biggest concern is really about how you the bottleneck that you get when you use this API gateway in the middle. And that's really why like Service Mesh became very popular. So with Service Mesh, basically, you have this notion of control plane on one side and data plane on the other side. And you basically configure all the rules that you want to enforce on the control plane, and these rules are then enforced by the data plane. And as you can see here, there is like a sidecar proxy that runs on each pod, and all the communication between the different pods are going through this proxy layer. So that allows things like encrypting the communication in a native way, so that you don't need to do anything at the application level. It's really the proxies that are doing this encryption. But also because all the communication goes through the proxy, then this proxy collects some telemetry data that you can use to know what's going on in your mesh. And as you can see here, this you probably recognize this logo, which is Envoy. And it's not a hazard why I put this logo, is because even if there are many different options in terms of service mesh, most of them now are like leveraging a sidecar approach. And most of them are like based on Envoy. So you have different solutions. Like if you look at Console Connect, for example, instead of having a single control plane, you would have like a control plane as a daemon set on each node. But they will still have a sidecar approach. And even if you can use something different than Envoy, Envoy is one of the options there. If you look at like Linkerd, if you look at other like Istio, obviously, like they're all based on Envoy. Oh, I don't know what happens with this. Sorry, let me try to just reload that. It's strange that. Yeah, so they are all based on Envoy, like I said, and it's not a hazard. I mean, first of all, it's like part of the CNCF, which make it like neutral, and it really provide high performance. You can really handle like thousands of requests per second with just a single instance, and it has really been developed in a way that is driven by API. So it's not like a lot of traditional proxy technologies where you were like creating a configuration file that was loaded by the proxy when it was starting to define the rules. Here, it's really designed to be driven by an API. So it's really designed to be driven by a control plane, which makes it really suitable for service mesh, obviously. And the next step after people start to adopt service mesh is quickly becoming like, how do I allow services running on different clusters or different environments to communicate together? And that's one of the nice things you can do with service mesh, especially with Istio. But it's not straightforward. You have several challenges there. I won't go through these challenges now because I'm covering that later in the presentation, but that's definitely becoming really popular to use service mesh to allow these cross-cluster communications. So as I said, I started with the challenges, and then I'm using that as well to introduce you to our different projects at Solo.io. Most of them are open source projects. And the one that people are familiar with already generally is called Gloo. And basically, Gloo is this API gateway that I discussed about before that allows you to expose your application to the outside world, even if these applications are not running on Kubernetes. And Gloo is also based on Envoy. So basically, Gloo is the control plane, and Envoy is the data plane. And one of the things that is very interesting about Envoy is this notion of filters. So you can create a filter chain so that when a request comes in, it goes through these different filters, and these different filters have access to the headers, the body, and so on, and they can modify them, and they can take decision based on them. And we'll speak more about these filters and the way you will be able to build these filters by yourself in the near future. But right now, what I want to highlight is the fact that when you deploy Gloo, basically Gloo comes with a set of filters already built in, and some of them communicate with other components running in Gloo, like external authentication server for OIDC or rate limiting server that is using like Redis as a backend, so that when a request comes in, it can send the request to this external authentication server to decide if this request should be allowed or not. And then it goes to the next filter where it can check if the rate limit has been reached. If it has not, then it continues to other filters that you can define if you want, like some to apply web application firewall rules based on mod security, or you can do some transformation, taking some data from a header to put it in another header, or things like that. And as I said, so Gloo is an open source project. As you can imagine, there is also an enterprise version. Everything about like data transformation is in open source, but everything that is more related to security is on the enterprise version. So like OIDC and web application firewalling and things like that. Another thing we've released quite recently is called like the Gloo Federation, which is a way to manage multiple Gloo instances in a centralized way. So you deploy Gloo Federation somewhere. It can be on a cluster where you have Gloo or on a different cluster. And you can then define all your routing policies and things like that in this cluster, and you can define which instance it should target. And it really allows you, in this case, to have like a central repository with all your rules, and it's easier to then maintain them, and you can have like a dashboard that shows you like what rules you have defined on the different places. But it's also provides some nice functionality like this one that I will demo quickly, which is like a failover capability. So you can have like requests coming for this application running here and going through this Gloo instance. And you can configure Gloo in a way that if it is not able to reach the service locally, it can reach a service running on another cluster going through another Gloo instance. So like this one running here. So I'm going to do a quick demo of that. I'm going to do that for the different projects. Obviously, I could spend like an hour on each topic, but I just want to give you like a quick introduction to these different projects. And obviously, slides are nice to set the scene, but it's always easier, I think, to get the value when you see a demo. So I'm trying to do like many small demos so that you get a good idea of these different projects. So let's start with the Gloo Federation. Like I said, you get this dashboard where you can see the different clusters, and here I have two clusters, so cluster 1 and cluster 2. You can see the different components like the virtual services and upstream that are configured on the different clusters. And you can see this one is a service where I have a failover configured. And basically, the way I've deployed it is that it's the same service that runs on both sides, but in one case, it returns blue, and in the other case, it just returns green. So that's the only difference, and I can show you that here. So you see, it's a blue-green deployment, and the text is blue on the local site, and the text is green on the remote site. So if I do a curl now, you can see I get blue because on the local site, I have like this code running here. Now, if I scale down to 0 replica, what will happen is that Gloo is configured here so that it has this failover set so that it knows that it can reach this other service on cluster 2 when it's not available on cluster 1. So let's see if it's already done. No, it's still terminating. So when it will be terminated, then I'll be able to send the same request to the local cluster. And instead of blue, I should get green. Still there, just for a few seconds. It's not there anymore. You see, I get green pod. So it's transparent for the end user. Like I'm not able to reach the service locally, but I'm able to automatically send the request to the other side. As I said, I could spend hours just on Gloo, but just wanted to give you like a quick highlight. The next project I'm going to introduce is on the service mesh side. And as I said at the end, when I was speaking about the challenges, one of the common challenge is how do I handle like cross-cluster communications? And here you have multiple challenges. Like the first one is about like federated trust and identity. So in the service mesh, basically you have like a certificate authority running, and you get a root CA, and basically each pod has its own identity. And this pod, when it communicates to this pod, they can do like mutual TLS because they are able to validate the identity of each other because they have the same, the certificates that they use come from the same CA. But if this one want to talk to this service here, then they have different CA so that they cannot really validate their identity. So before you can allow cross-cluster communication in a secure way, you need to federate the identity. So that means that you need to create a common root certificate that will be used to create like a or will be used to sign the intermediate certificates that are different on the two clusters. And then these intermediate certificates are used to sign the certificate of each pod so that now this pod can trust requests coming from the pod on the other side. So that's one thing you need to do. Then you need to, create some, or you need to configure a lot of things to allow communication from one side to another, because this cluster or the pod running here is not aware of the pods running on the other mesh. So you need to have a way to make this cluster aware of these services, and also to indicate how they can communicate with them. And basically it's using like the edge gateway, and with Istio it's the Istio Ingress gateway. But you need to configure a lot of things to make that happen. And you need to also then have a way to manage access control globally, because now it's not about just like one mesh isolated from another. It's really like a lot of different meshes like that can talk together. So you need to have this this global access control. You need many other things, but what's important is that each one of them is highly complex. And that's really what Service Mesh Hub does. It simplifies everything. So let's take an example for a quick demo. So we have this, for people who are familiar with Istio, we have this book info application that is used for demo purpose, where you have this product page, which is a microservice that basically is the front end. And this front end talks to different backend services to get reviews and ratings and details and so on. And here what we are going to do is we are going to distribute the request coming from the product page to the reviews, so that it sends some of the requests on the reviews locally and some of the requests on the reviews on the other side. And you see you have V1 and V2 of the reviews here, and you have V1, V2, and V3 of the reviews there. So we'll be able to use the fact that there is V3 only there just to make sure that the requests are going through the other side. So again, quick demo on that. So I'm going to switch to another environment, which is there. And what I'm going to do is just to show you, first of all, what I see now. If I try to access this front end. So you see, this is the product page, and you see the review. When you have no stars, is the V1. If I refresh, I have the V2, which is black stars. But if I refresh several times, I never see the V3, which is red stars, because right now I only have like local communications. So to allow that, I'm going to create like a traffic policy, which is like a service mesh hub object that you create on Kubernetes. And you see it's very easy to understand. Basically, what I say is that when I send request to the review service on cluster 1, I want to distribute this request that way. So I want to do like 75% of the request going to the version 3 on the cluster 2, 15% on V1 on cluster 1, and 10% on V2 on cluster 1. So it's very straightforward to describe what you want to achieve. And just like creating this object basically should make it happen. So I just create it. And if I go back in my UI here and I refresh, I should start to see red stars. You see here, I get already red stars, so which is the V3 on the other side. And if I refresh 3 times out of 4, I should get the red stars because I said that I want 75% of my request to go to the second side. Again, now I get like some requests are still local. So what's nice, you just create CRDs to define what you want to happen, and it's just enforced by Service Mesh Hub. So that's for like the traffic, but then you have something similar for access policies. So you can define, I want like the reviews to be able to communicate with the rating service, for example. And you define on which cluster, so you define your access policies globally. And then you can use the UI of Service Mesh Hub so that you can see what's going on. So here I can see I created a virtual mesh with my 2 clusters. So when I did that, it has allowed me to federate the identity like I described before. And then I created policies. So like the one I just created here, which was like with, let's go here. So it was called like simple. And you see, that's what I described in my YAML, like 75% going to cluster 2 and 15% to cluster 1 and so on. And what's nice is that you see what are the targeted components. And the same when you apply a policy for access. So I described this one for reviews. And what's nice with the UI is that it tells me what are the current workloads and targets in my cluster that are impacted by this policy. So again, just like a very quick overview of what you can do with Service Mesh Hub. You can do much more, but what I really want to highlight is that by creating this traffic policy here, basically Service Mesh Hub has translated that in multiple objects, multiple Istio objects. So if I would do that manually, I would have to create like a virtual service, Istio virtual service that is quite similar to my policy that I've just created. Then I should create a destination rule for each label, for each version, that for each subset that I define here. Then I would have to create a service entry to tell Istio how to reach this service on the other side with the IP of the Istio Ingress gateway on the other side and so on. Then I would have to have like an Envoy filter to rewrite my .kind3.global by cluster.local, and then destination rule to reach this service locally and so on. So again, it's not important to really understand all these different objects, but just like one very simple to write object is creating all these Istio objects to make the magic happen. And what I've shown you how to do that for like multi-cluster traffic, but you can also do that for like service-to-service failover, a little bit similar to what I described before when I went through this Gloo Federation, but for Istio. You can do much more. You can also combine them together. So you can have like Gloo as a replacement of the Istio Ingress gateway for the request coming from the outside world. If you want to take advantage of some features you find in Gloo, but you don't find in the Istio Ingress gateway. And that's it. I mean, for the Service Mesh Hub project. Another project I want to introduce you to is like what we call a developer portal. And what's interesting with the developer portal is that you can use it with or without a mesh, and you get exactly the same experience. So if you don't have a mesh, then it will enforce the rules on Gloo. If you have a mesh, you can just configure the portal so that it will enforce the rules on the Istio Ingress gateway. And in both cases, it works exactly the same way. So I'm going to show you the developer portal on Istio because that's what I have in the environment running now. But that would be exactly the same if I don't have a mesh and I just want to use it with Gloo. So again, I'm going to do a demo. It's a lot easier for you to understand the benefit of the portal than if I just like use slides. So going back to my environment here, I have a developer portal, and this is the admin view of it. So basically, when I come here, I can see I have exposed my API with one portal. And the way you do it is that you, first of all, create what we call API docs. So an API doc basically is like an open API specification that, or a Swagger specs that you either you upload these specs or you just like paste a URL, and it will use these specs to define what functions are available in the API. And here you see, you can go there and you can say, I want to create an API and do that like in the UI. But obviously, you can also do that through the CRDs. So everything is based on CRDs, when I've showed exactly like with Gloo and with like Service Mesh Hub. All of these projects they have the same concept where you can define the configuration with CRDs, and then you can use like a UI and dashboard to see what you build and what's going on in the system. So here, instead of going through the UI, I could just create, and this is what I did to prepare the demo, like just creating an API doc CRD so that create this API doc in my portal. But then, and that's the API doc here. But then what you want is that you want to expose this API to the outside world. And sometimes what you want to expose is an API that is based on multiple microservices so that each microservice will handle a part of the API. Or you want to expose just a subset of the API that is running on this microservice. So that's really the purpose of an API product. So basically, an API product, you have multiple API docs. So here I have just one, but imagine you could have several ones. And then you can define which functions of each API doc I want to expose in this API product. And then you can define as well plans and say, I only want to allow authorized access with API keys. And I want also to create a rate limit in this plan so that people who use an API key from this plan, they can only send 5 requests per minute. And then you will be able to expose this API doc in a portal. So one portal can be used to expose one or several API docs and API products, sorry. And each API product can be composed of one or several API docs. And as I said, you can enforce access, who can access it, with OIDC or basic authentication. And as soon as you check this box, like root enabled, what it does is that it creates automatically the routing for you. So if I am like running on Gloo, it will create like the Gloo components, the Gloo objects to expose the application. If I am on Istio, it will create like the corresponding Istio object. So for example, that's my Istio virtual service that is created by the developer portal to expose it. And finally, as I said, you associate your API product to portals, and when you define your portal, you can brand them the way you want. You can change some of the colors. You can even like completely override the CSS style sheet so that it really looks like you want it to look. You can add some pages to your portal that can be static pages, but even dynamic pages that load in the context of your user or in the context of your API. And then you can define also access control at that level. So you can have different level of access controls. And the user experience is that then you have this portal that can be accessed by your end users, and your end user can log in with either OIDC or local user. So here I just like have like a local user. I have to remember the password I put, which is not that. Let me remember. That's not that. I always change the password I use. Okay, so I'm just going to go there because I automated everything there. So I should be able to find which user I used, which was, it was password. It was a very complicated one. That's why I didn't think about it. So I log in here, and the first time, if it's a local user, I ask you to change your password. Otherwise, obviously, if you use OIDC, you don't need to do that. And then when I am logged in as a user, I can create my API keys. So let's say I create an API key here, and I can click on it to copy the contents. And now if I go to the APIs that are available and I can try them out. So I can just say, there is this like API call for like getting the products. And if I click on trying out, I can click on execute, and here I see I get like a 401 response code because I didn't specify my key. So to do that, basically I click on authorize, and I can paste my key here. And now if I run it again, it should be a load because I have my key, and you see I get my 200 response codes. And you remember I have a plan. I can just do 5 per minute. So if I click on execute, several times, then I should get like, you see, 429, which is like too many requests because it's rate limited. Obviously, the goal is not to use the API that way. Then like your clients are using them with like their own code or like curl or whatever. But it's very convenient to have this way of, to test your API and things like that. So that's the developer portal. And basically, I spoke about our current project that people use in production. Now let's speak about the future. So the future is really WebAssembly. And not only WebAssembly Hub, I should even not call that way, but WebAssembly in general. So WebAssembly is really the future of that will, the way you will extend Envoy in general in the future. And why we need that? Because currently, you remember when I discussed about Gloo, I said that we have this filter chain. And basically, the way we build these filters at solo.io is that we use like C++ to create these filters. And then we basically need to statically link it to Envoy. So we compile everything together, and we ship a new version of Gloo with all these filters. So it's not easy because obviously C++ is not really the language of choice for many people. And also it's not dynamic. You cannot just load a new filter when you need it. And the good news is that the Envoy community has worked hard, and we participated to this effort to allow people to run WebAssembly filters in Envoy. And WebAssembly has been designed at the beginning for the browser as a way to run some codes from JavaScript that is not written in JavaScript. And that's used now in Envoy, and basically you have some SDKs that exist in multiple different languages. Like you have one in assembly script, one in Rust, one in TinyGo, and you can use this SDK to build your filter in a language that is more accessible than C++. And then what we did at Solo.io that we created this WebAssembly hub. So it's really the same idea as a Docker hub. So you use like a CLI that we provide that's called WASMI, and you have like different options. One is like a Docker build. You do WASMI build, and it will compile your WebAssembly from the language you decided to use. Then you would do like a WASMI tag, like you would tag like a Docker image, and then you would do a WASMI push, and it will push it in the WebAssembly hub. And then when you want to use it, you can do WASMI deploy, and it will just like deploy it in your environment. So that can be deployed on Gloo, that can be deployed on Istio. You have multiple choices there as soon as it's Envoy behind the scene. So it's really the future. It's not really ready for production now, and I shared some links there so that you can see and learn more about it. My colleague Christian has written this blog post that is really useful if you want to understand the current status, and also like what you can really get from it today, and where it is going. So for some time it was like a separate project than Envoy. Now it has been merged upstream, but still there are some stuff that are evolving, like the what we call the ABI is not that stable yet, and the SDKs are still evolving. So a lot of reasons why you cannot really use them in production now, but it's coming very soon, and here you can get a lot of information about it. So I really encourage you to read that. Basically, the one of the nice thing with it is that because you can apply this filter anywhere, you can apply that in Gloo, and then that will be a new filter in your filter chain for the request coming from the outside world. But if you apply that on Istio, you can apply that on the Istio Ingress gateway if you want to also modify the request coming from the outside world. But you can also use that for enforcing some rules in your east-west traffic. So I have my microservice A that talks to microservice B in my mesh, and I can now modify this request basically using a filter that I create on using WebAssembly. So imagine now you have like a lot of possibilities, a lot of things that you can do to make like smart decision on your service-to-service communication. I also want to highlight that we also have like workshops that we are delivering, one very soon. I think we have a few remaining seats if you want to learn more about Gloo. And we have a Service Mesh Hub workshop also in a month. So feel free to register. They are very easy to find. You just go to the solo.io website, resources and events, and you find all of them. And that's a way for you to learn more about them. Also wanted to highlight that we are hiring. So if you are like fluent in English and Kubernetes, which is probably the fact for all of you, and you have some knowledge on either like Istio or API Gateway or Envoy, like we really look for these profiles. So please reach out to me, and I will be very happy to talk with you. So thank you. I think we have a few minutes for questions now. So I don't know if there are some questions either in StreamYard or in in YouTube. Oh, I created a bad effect by doing that. So
maybe that was my mistake. I already edited ourselves.
Unlimited screens.
Yeah, thanks so much, Denis, for the presentation. We do have, if we still have a couple of minutes, we got to 2 questions. First questions, is all of this, everything that you presented, is this free to use for the developers? Or is it some paid plan?
So that's a good question. So like, as I said, the Gloo, we have an open source version and we have an enterprise version. The Service Mesh Hub is open source. So everything I have shown you, you've seen on Service Mesh Hub is open source, but we have an enterprise version coming. And the dashboard you've seen will be part of the enterprise version, and you will have some special features there as well. But there is this open source version. All the traffic, between clusters, all these things, it's open source. All our effort on the WebAssembly side, like WebAssembly Hub, all this stuff are free and open source. The only component that is only enterprise is the dev portal on all the things that I've shown you.
Cool, thanks. And then we had another question. If I understood it correctly, it means basically, is everything in Gloo built on top of Istio, or is it only on top of Envoy and it works with different service meshes?
So everything I have shown is built on Envoy. Like Gloo is based on Envoy, and you don't need a service mesh. Basically, Gloo can work with a service mesh, but most of the people are using it without a service mesh. And basically, what a typical deployment with Gloo would be like, you would have like Gloo is the control plane. You have one Gloo running in your cluster, and then you can have multiple instances of Envoy. Like, let's say a very common way is to have like 2 of them, and so that you get HA. But you can scale to more if you need more performance. Obviously, it's not very common because you get a lot of performance with Envoy. So with 2 instances in general, it's more than enough.
Okay.
I had another question. So Denis, the thing is, it's a little bit on a tangent. So I sometimes see these projects where you basically have more YAML files than source code. At what point does it make sense for a company or a startup to start looking into microservices and add all this overhead of needing to learn the tooling of orchestrating this whole thing?
I mean, like, I would say that the microservices decision is generally taken for other reasons. Like, you cannot handle the monolith anymore. You want to scale it, different component differently. You want to be more agile and so on. But then when people took the decision to go and use microservices, and they took the decision to go to run on Kubernetes, then in any case, they need to expose them to the outside world, and they need to think about how they can be smart about this service-to-service communication. So then they need to find what's the best way, and obviously you can use like some legacy tooling for that. But the benefits of using things like Gloo or other projects we have is that because everything is based on CRD, you can really automate everything. So that you can, and I mean, like, most of our customers are really using a GitOps approach when it comes to configuring Gloo. So they have like all their YAML or Helm charts, and then they put that in a repository, and they use like a GitOps tool, like, I don't know, Argo CD or things like that, to enforce the rules on the cluster. And then basically, so they handle that, with this infrastructure as code approach, and then they want to have this dashboard so that they can see, what they've configured, what's the effect of everything, or the status on things like that. So
but I assume it's not a 3-person startup, your typical customer.
Oh, no, it is. We have like a lot of very small customers. We even have a starter pack so that we promote this usage. I mean, like, startups, generally, they develop new applications, obviously they start with microservices right away. You know, they start in the cloud. They start, you know, with Kubernetes containers. So then when they have to decide about an API gateway, because they don't want to, you know, they don't want to develop like all the authentication layer in the microservices themselves, and they don't want to do all these things there. You know, they want to. Then they have to find what's the best, you know, gateway for that, and obviously Envoy is kind of a logic choice. And then when they find a gateway like Gloo, where they can define everything in CRDs like they do for the rest of their application, that makes a lot of sense for them.
Do you offer this as a managed service as well, or as a software license?
No, it's a subscription. Yeah, it's a yearly subscription.
Yeah, thank you so much. I
know.
Thanks so much for joining us. It was really cool. Yeah, thanks, and hopefully see you again soon.
See you. Bye, guys.
Thanks, Dennis. See you.
Yeah, as said, Dennis is jumping off a little bit earlier. As he's going to present at the CNCF webinar starting in 2 minutes. And I think we're already handing over to János to start with his presentation on a topic around building your scaling with Prometheus metrics, right? Something like this.
Yes, that is correct. You should have my slides already on the screen.
Building autoscaler. Pretty cool. Yes. Yeah, we also give you the stage to introduce yourself, and yeah, we are looking forward to the presentation.
Yeah, thank you very much. So thanks for having me, first of all. So this is a very interesting topic that I developed a while ago. And well, as mentioned earlier, I'm currently working as a lecturer at the FH Campus Wien, which I will continue doing. So this is kind of like a side gig, and I'm starting with Red Hat next week. I took the past 1.5 months off to build a couple of interesting things. This autoscaler is not the only thing I built recently. So if you're interested, you could take a look at Container SSH, which is a cloud native SSH server that talks to the Docker and Kubernetes API to launch containers for each session. It's completely open source, and we just put in significant amounts of effort to getting it, let's just say, user friendly. There is a very good documentation. Take a look, and if you want to use it, contribute, let us know, and have fun with it. So this is basically what I do. Now, why are we talking about autoscaling? After all, Kubernetes already has a horizontal pod autoscaler, it has a cluster autoscaler, and there's like a 5 bazillion other solutions as well. Azure has their Azure autoscale, Amazon has their AWS autoscaling groups, etc., etc. So is there even a need to talk about autoscaling? And one of the things I am recently conflicted with is it seems like this is solving an issue that we don't really have. After all, when you're a small startup, then your autoscaling needs are very modest, and most likely you can just use whatever your cloud provider is providing. On the other hand, if you are a larger company, then you are probably stuck with some sort of a legacy infrastructure, and scaling isn't even on the horizon for you. Or if it is, then you wouldn't be taking advice from me. The thing I found with autoscaling is, first of all, you might be working in a large company that has an on-premises system, and you would kind of like to go into the direction of the cloud, but you're not quite ready to use a public cloud provider. So in that case, a little bit of orchestration around creating and destroying VMs could be actually quite helpful. The other thing that I found is usually a problem, and this appeared on the Kubernetes users Slack channel as well. On the official one is composite metrics. So composite metrics are when you take the CPU metrics and the memory metrics and some custom measurements from your application and whatnot, and then you make a scaling decision. So for example, what I did in the past is work on web hosting. Web hosting was kind of my pet project for a good almost 10 years. And the issue there is that when you're running web hosting for PHP, is PHP it doesn't really have a good metric in terms of CPU or RAM. Rather, the PHP FPM starts one process per user. And then what you run out of very often is the number of processes that you can run. So your scaling decision might be based on something very, very custom. The other thing is vendor lock-in. A certain level of lock-in is, of course, to be expected when you move into the cloud, but you don't want to go full crazy with using everything the cloud provider has, because you will never ever be able to move if their service offering is too expensive or you decide that you don't want that anymore. I recommend looking at Netflix's talks on how they moved from using everything in the cloud to building their own edge CDN kind of thing. The other thing is you will have a monitoring system anyway, and it's most likely going to be based on Prometheus and or Grafana, and it's a very good piece of technology, so why not use it in conjunction with your application? So do more with your monitoring system. And that also leads into learning something, because a lot of people are using Prometheus and don't necessarily understand how this works or how to add custom metrics to their applications. So this is also what this talk is about. So let's see what we are going to build today. The first thing is we're going to take a couple of virtual machines, and virtual machines are just that. So there is a Linux running on them, and we will be scaling those. We are going to install an HTTP server. This is a special HTTP server that I wrote that specifically generates a very high CPU load, as a demonstration, of course. And we are going to be running that, and we are going to run the Prometheus node exporter. And the Prometheus node exporter is the piece of software that gives the CPU and RAM and whatever metrics to Prometheus, and we'll see in a moment how that works. What we will use from our cloud provider is a load balancer. If you're running an on-premises system, then you will have to figure out how to do that as well. And we will run the whole thing in a scaling group. And the scaling group in this sense means that whenever a new VM is needed, then the scaling group will provision that VM. And if there are too many VMs, then it will destroy that VM. If a VM crashes, it will destroy and recreate that virtual machine. We will also install a monitoring server, and that monitoring server will, of course, run Prometheus. Prometheus will be fetching the metrics from the Prometheus node exporter, and it will know which VMs to talk to in the scaling group using the service discovery agent. The service discovery agent fetches the IP addresses of the VMs running in the scaling group every 15 seconds or so and updates Prometheus to make sure that it also always has the up-to-date IP addresses. And this is already where Prometheus begins to show its strength, because if you are using a classic monitoring system like Itzinga or even older things, then those are mainly built for static IP addresses. Of course, Itzinga 2 now has methods to update the database, but it's scripting, it's hacky, you have to put in a lot of work, and Prometheus does most of that itself. We will use Grafana. You don't necessarily have to, but it is a very nice dashboard, so why not use that as well? And we will use a small component that we write ourselves called the autoscaler that will be triggered by Grafana webhooks. So this is the setup that we will be looking at today. Now let's look at the scaling group first. So the thing is, when you look at the cloud, the way that virtual machines are provisioned is from an image. And this image often contains a piece of software called Cloud Init. Or if you're running Windows, then often an alternative version from a company called Cloudbase, so the Cloudbase Init. And this Cloud Init is talking to the metadata server of the cloud provider. This metadata server can give you a large number of fields. For example, you can fetch your own IP address. On Amazon, you can fetch your machine-specific API keys. You can fetch many other things. And the most important to us is the user data field. And this user data field is a YAML file or a shell script, can be both. In the YAML file, you can do a little more, but in our example, we will use a shell script. And this shell script will be executed when the machine first starts. So we will use the user data script to install our software components, so the HTTP server and the metrics server on our virtual machine. So whenever a new VM comes up, it automatically has the right piece of software. So the first thing we are going to do is, of course, install Docker. We are not using Kubernetes in this example, but again, you can extend this very easily to Kubernetes as well. First thing is, please don't use this script in production. I hope I don't have to say that. We will use the convenience script from Docker, again, not recommended for production, and install Docker using that convenience script. The second thing we are going to do is install the web server using Docker. So what we're going to do is do a Docker run, -d runs it in the background, and we're going to give it a restart policy of always. This restart policy is going to restart the web server whenever it crashes, although that is very unlikely. We'll also expose the web service on port 8080. If you don't know how the Docker commands work, then the manual is very, very well written, so please take a look at that. And finally, we are going to give it the image name, and you can use this image name if you ever need a load generator. So this is my nickname /HTTP load generator version 101. The second thing, we are going to install the node exporter, again with the restart policy always, and we are going to run it in the host network namespace. The namespaces in Docker and in containerization are a way to isolate containers from each other and from the host operating system. So there are multiple namespaces, the network namespace, the PID namespace, UTS, etc. I have a whole talk on that topic. If you want, you can look it up. Or, of course, if you prefer reading, there is a blog post about that too. The main point is that our node exporter is going to run unconfined in terms of networking and in terms of reading processes, and this is needed by the node exporter. We are also going to mount the file system from the host operating system into the /host folder. Again, this is normally very dangerous if you're running some untrusted software, because the container would then have access to the whole host operating the file system. But in our case, the Prometheus node exporter needs that to be able to read the metrics of the host file system. So, for example, how full the disk is. And then we are going to pass it the image name. This is quay.io /prometheus/node exporter. And we're going to pass it a parameter called --path.rootfs is located in /host. So that's it. Our instance pool is now ready. And every time a VM comes up, it will install the HTTP server, and it will install the node exporter. So let's take a look at the second part, the monitoring server. If you look at the second part, and specifically the service discovery and the Prometheus, this looks as follows. First of all, we're going to write a Prometheus config. This Prometheus config will have a scrape config. The scrape config, you can provide multiple scrape configs, is what tells Prometheus where to fetch the metrics from. And in this case, what we're doing is we're going to provide it a file service discovery config. That means that Prometheus will, every 10 seconds, as you can see, fetch this config.json file and use the IP addresses in there. So whenever we update the config.json, Prometheus will update its IP address list. We start Prometheus, just again with Docker run, --mass restart always, expose port 9090 on the monitoring server, and we pass it to Prometheus YAML in the folder ECT Prometheus YAML, and we pass it a special folder. This folder almost doesn't matter what it is. In our case, we're just picking srv/service discovery, and we are launching prom/Prometheus. Remember, the srv/service discovery/config.json is the file where we provide the IP addresses. So this folder is important, the second one, so we can provide the IPs. Now, the service discovery agent needs to provide the IPs in this format. So you have a JSON file, it has an array in it, and then an object, and then there is a target, and then you provide the IP addresses and ports of the metrics endpoint that Prometheus is supposed to fetch. You can also provide some labels, and these labels are then attached to the metric. You will see later what these are. The main point is we will provide these IPs. The way that we will do this is a very, very simple shell script. This is not, again, something that you should do in production, but it is a very useful way to showcase what I'm doing. In my cloud provider, in this case, is Exascale. This is what I built the demo for, and I'm just listing the instance IDs. Then I am looping over these instance IDs, so I'm running the code between the for and the done. For every single instance, I'm fetching the IP address of that specific instance in the instance pool. And then I'm just writing that to a temporary file. Of course, I need to add something before and after, but basically this is also a very, very hacky way to produce a JSON file. Needless to say, in production, you shouldn't do this. Rather, you should take a language like Go or Python to produce this JSON file properly. Now, you can, of course, do this with other cloud providers. So with AWS, with AWS Autoscaling, describe autoscaling groups. Azure is the AZ, VMS, list instance public IPs, or in the Google Cloud, it would be Google G-Cloud Compute instance groups to list the instances in an instance pool. Whatever. Of course, the name is always different depending on the cloud provider. Now, what if you don't want to do the service discovery? You can, of course, look at the Prometheus configuration, and you will see that there are a bunch of drivers for Azure, DigitalOcean, Docker Swarm, Amazon EC2, etc., etc. The only thing you have to take care of, if you have more instances than just your autoscaling group, then you will need to label the autoscaling group appropriately, so it only fetches the metrics from the autoscaling group, and you have the necessary labels to make decisions only based on your autoscaling group. Okay, let's take a look at the next part, and that's going to be how Prometheus fetches the metrics. If we look at Prometheus, we click on status and then targets, we will end up on this screen, and this screen will show us the IP addresses that we have provided in the config JSON. And you can see the URL there, which is /metrics, is where Prometheus fetches the metrics from. If we open this URL in our browser, we will see something like this. The first part here is the metric itself. In this case, go GC duration seconds. Then we can also provide one or more labels. These labels are basically filters, and we can do wonderful things with these. I will show you in a minute. And finally, we will provide the actual number of that specific metric. There are some other things like what metric type it is, some help text, etc. But this is the basic idea. You can write your own Prometheus exporter for your application. So if your developers just want to give you some metrics, then this is the easiest way. They should just need to provide a metrics endpoint, and from that metrics endpoint, you can fetch the application-specific metrics. Now, if you are really interested in doing that, I would recommend reading this piece of documentation. This is the exposition formats documentation, and this is now being standardized into something that is independent of Prometheus. So this is a fairly standard way of doing things, and this will be a good thing to implement for the future, even if you're not using Prometheus. Now, if you open Prometheus, we can, of course, then see this very, very bare bones screen, and we can look at the metrics up there. And the metrics up there in my example look like this. This is written in a language called PromQL, so the Prometheus query language, and you can see that we can do a bunch of things. I'd like to take one piece out. This is the node CPU seconds total. This is the metric name, and we are fetching all the metrics that are node CPU seconds total that don't have the mode idle. And what we're doing here is we are fetching the CPU usage. So this is split into multiple metrics with labels. And these metrics are then need to be aggregated then. So for example, we take the CPU usage in user mode and kernel and whatever not, and we sum those up by instance to get the current CPU usage since the start of the VM. And we divide that by the total number of CPU seconds since the start of the machine, and that's how we get with the rate function, we get the current CPU usage. And then we can, of course, average it by instance, and that will show us a very nice average graph of the CPU usage of each instance. So that's already very helpful. So let's take a look at how Grafana then gets this information. Grafana, as I said, is a very wonderful little piece of software that gives us dashboards that we can click together, and we can set up alerts, and it will send us webhooks and notifications to PagerDuty and whatever not. The important part for us is that we want to have it installed, and that is very, very simple indeed. We run Docker run with the restart policy of always, of course. We expose port 3000, that's the Grafana web server, and we pass the image name, and that's it. Of course, in production, you would need to do some persistence for your configuration, or you would need to provide the dashboard and the metrics as part of the startup sequence, which is also a possibility. Again, I have also written a few blog posts on that topic, so feel free to dig through my blog. When you open the Grafana dashboard, then this is what you are greeted with. You can enter the username and password admin. Of course, you should then immediately change it, and then you see this. And you can, as a first step, click on the little cogwheel icon and then click on data sources. And in data sources, you click the data sources button and you can see that Prometheus, among many other things, is already supported. So then you click the select button and you set up a new data source in Prometheus, and this should be on the public IP address of your monitoring instance. So we are basically telling Grafana where to find Prometheus. You can, of course, use Docker networking to do that internally. In this case, it's a lot easier if we do that publicly. So we just enter the port 9090 where Prometheus is listening, and then save everything, and then click on the plus icon. The plus icon will let us create a new dashboard, and then we add a new panel. And this then greets us, which looks like it's a NASA dashboard. And oh my God, there are a lot of buttons here. So what we're doing here is we click in the metrics field, and you can see already that the default backend is the Prometheus one, and we enter a PromQL query. So let's copy in the little metric that we previously did, and you can see that a green and a yellow line is appearing in the graph above. This is very nice because now we see per instance what their average CPU usage was over the last minute. We can also go to that little legend field in the bottom and enter a legend to make the labels there on the graph more readable. So this is basically how you configure Grafana. You can then look at the visualization settings and make the graph look very, very good indeed. There is a map plugin, so you can really feel like you're in some sort of a James Bond movie and you're looking at the world map where the nukes are being launched or what have you. So yeah, well, isn't that everybody's dream to have a control panel like that? Grafana can do it. Now, the interesting part for us, though, is not the let's feel like a James Bond villain, rather the alert section. If you go to the alert section, that will let us create the webhooks that we so desire to drive our autoscaling. Let's take a look at how that works specifically. We go to the little bell icon and then to the notification channels. And in the notification channels, we are going to create a new notification with the name scale up, type webhook, and in the URL, we are going to enter the public IP again of our monitoring server. And this time we are choosing a port that we did not use before, port 4000, and we are going to enter the URL /up. The /up URL is going to be the scaling up webhook, and the /down URL is going to be the scaling down webhook. We scroll down and we need to check a few additional settings. First of all, we need to disable the resolve message. Otherwise, if the CPU usage goes back to normal, then Grafana will send another webhook, which will scale up our instance pool again unnecessarily. And we will also set the send reminders option. The send reminders option can send a reminder every 15 minutes if the CPU usage is still too high. So let's take a look how that works. We have first CPU usage of 30% and then climbs up to 90, and then 90 will send a webhook, and that webhook will create a new instance. And then, of course, the CPU usage is still high, and then yet another webhook is sent because of this set reminders feature that will start another VM, and then finally the CPU usage falls, and then no more new instances will be started. So if we go back to Grafana then, we can change this little formula here, this little PromQL query, to give us a single metric. Instead of using an average by instance, we're using an average over all the instances, and this is the metric we are going to use in terms of CPU usage. The alert section is then set up in such a way that we have an 80% threshold. So if the CPU usage climbs above 80% over 1 minute, then it will trigger the scale up notification. So this is something we have to set up. We can, of course, then set up an according graph with the scale down notification if the CPU usage falls below 20%. And then this is how it should look like. As you can see, the graph on the left is triggering the scaling up, and the graph on the right is triggering the scaling down. So let's install Nginx and on the monitoring server. This is, again, a very non-production ready solution. So apt install Nginx, we are going to install a little extension libnginx mod http Lua. So this lets us run some Lua scripts from Nginx, and we need the JQ utility. So let's write the Nginx config. Don't do this in production, please. We are writing into the file etc Nginx sites enabled default, create a server block, listen on port 4000, and create a location handler for /up Again, this is where the webhook goes, and we are going to execute this shell script called /srv/up.sh. We are also going to do a scaling down equivalent for /down, which is going to launch the down.sh. So how does one more thing we need to do is we need to set up an API key for these two shell scripts, and we need to restrict it to only be able to scale the instance pool up and down. Otherwise, we don't want to give this little script root privileges. That would be overkill. Now let's take a look at this up.sh. Don't use it in production. Set -e will make sure that all errors immediately lead to failure. We will declare a maximum size for our instance pool. After all, our budget is limited. And then we will fetch the current size. I did not detail the script here, but basically this fetches the number of instances in your instance pool. If the number of instances is smaller than the maximum size, then we increment the size by 1 and then set the new instance pool size, and our cloud provider will immediately take care of provisioning the new instance that we need. Again, the reminders will make sure that this script is called repeatedly until the CPU usage falls below 80%. So let's test it. We are going to use Apache Benchmark, and we are going to fire away 2 parallel requests and 1,000 of those. We fire them against the load balancer on /load. /load is the special URL that generates the load. And we can see that our script will be working. We can see that the instance pool is scaling up. And in our little graph, we can see that initially it started with 2 instances. Then the autoscaler decided to scale it down in the bottom right corner to 1 instance. And when the CPU load hit, then it scaled back up again. Now, the little yellow and red things here are the interesting bits, which I will show in the demo. But before we come to demo, let's talk about redundancy, because this is actually not production ready, as I mentioned. One of the things with Grafana is that it's very, very beautiful, it's very useful, but it is kind of hard to make redundant because you need to provide a redundant database behind it. Instead of Grafana, you can also use the Prometheus Alert Manager, which in and of itself can do clustering. So the Prometheus Alert Manager can be redundant, and then you can set up 2 Prometheus instances which collect 2 or more, of course, which collect the metrics independently and send them to the Prometheus Alert Manager. And the Alert Manager can then talk to the autoscaler, which is located behind the load balancer. This is done because the autoscaler is actually stateless, because it always looks at the current instance pool size and increases or decreases it, but it doesn't matter if there are 2 parallel autoscalers running, because one of them will receive the request and will deal with it accordingly. So a few recommendations on my part. Again, please don't use shell scripts. Please learn Go, or at least learn Python. Go is in this sense preferable because it's much easier to containerize than Python. And it will let you write something like this in a couple of lines of code. And then now we are switching to the demo, and I will just change my screen share in a minute if I can find the appropriate button. Share my screen, entire screen, there we go. And now I made the screenception. So you can see that I have already set up the infrastructure here. My monitoring instance is running here, and my instance pool is already running, and it's running 1 instance. This is done using a Terraform script, because I am using this for my FH Campus Wien lectures as well. So this is one of the projects work that the students have to do to prove the Terraform code will be released mid-December. Now, if we look at the Grafana section here, you can see that I have 3 graphs here. This is the low CPU usage, the high CPU usage, and the instance pool size. If we go into the data sources section, you can see that I have Prometheus set up. In my case, I did some internal networking, so this is a little different than in the demo, but you can the whole configuration is basically the same. And if I go into notification channels, you can see that there are both the scale up and scale down webhooks, and they are set up as shown in the presentation. Now, if I go to my dashboards, what happens if I hit the endpoint of the network load balancer? I'm going to give this IP, and this is going to load for a while, and then it's going to generate some CPU usage. You can see that the CPU graph is already climbing. Prometheus has a quite a fast update rate. So we will see that it's going to be a little bit of a bump, and then it's going to go back down. Nothing too serious. This is not going to trigger a scaling event. So let's hit it. What we are going to do is AB minus C2 minus N 1000 requests, and we're going to grab this wonderful little URL and then punch it to make sure that there are some events happening here.
János, can you just make the screen a little bit bigger, the font size, and also
yes, there we go. How's this? So you can see that I'm using the Apache benchmark tool against the load generation here, and now the CPU usage is actually climbing quite rapidly. The low CPU usage is now back into green, because when it was under the red line, it actually continuously triggered the scaling down, but the script prevented it from scaling down below 1 instance. And you will see in a moment, this graph will climb into the red area, which means that, first of all, it will enter the yellow state. The yellow state in Grafana is the pending state, and in the pending state, it will wait if it goes back down. And you can configure how long this pending state is to make sure that sudden spikes don't trigger some erroneous alerts. And if it stays in the red area, which it will, then it will enter the alerting state, and in the alerting state, it will actually send the webhook to our autoscaler. This should just take about 2 minutes to happen. In the meantime, if there are any questions, I would be more than happy to answer. Otherwise, I'm just going to look at these beautiful little graphs to see what's going to happen, and if the demo gods are indeed with me this time. There we go. There is the pending state. It says that now Grafana is evaluating if this is actually a real alert, or if it's just something that spiked suddenly and already goes back down. This is just going to take 1 more minute to go into the alerting state, and then it will start the new instance in the instance pool. Before it goes into the alerting state, nothing happens here. So the webhook only gets called once it's in alerting. And it should happen any second now. There we go. There is the alerting state. So that means that a webhook was triggered. We can look at it in the alert rules. Scale up. If this is actually under load, this is a little slow to load. I provisioned a very small instance for this, so this might not, yes, this is not loading. But in this screen, there we go. There are already 2 instances running. So that was quite quick, which is not unexpected. This is one of the features that Exascale really likes to highlight. I used to work for them until August. So that's why I'm still using them. You can see that there are 2 instances running now, and the CPU load should go down once the new instance is provisioned correctly. This is going to take about another 1 or 2 minutes, because the user data script actually needs to execute, install the web server, and once the web server is installed, the network load balancer health check will be green. You can see this is still a high CPU usage. It starts going down once the second server starts taking part of the load. Do we have any wonderful questions in the meantime?
I just add us back to the stream. So you mentioned everything you built here is open source. Maybe in the meantime I can post the link, or is it on your private GitHub repository?
So the Terraform code for this will be made open source in mid-December, because this is a project work that the students need to hand in. So that's why it's not open source yet. Okay. I can paste the link. Yes, you can see the CPU usage is now going down because the second instance kicked in. So there are a couple of repositories. The FH Cloud Computing repository, I will share that in a minute, is one of the repositories where the learning material is. I can actually open that real quick. So this is fh-cloud-computing.github.io. This is where the learning material is if you want to go through the exercises and the lectures yourself. And there is an original article about this autoscaling behavior on the Exascale blog. So you might want to take a look at that as well. If you want to build something like this, the Exascale blog is probably the easiest to follow because those are the manual instructions. And these are the instructions and the building blocks required to do an automation using Terraform.
Cool.
Yeah. Okay. And that is basically it. If there are any more questions, I'm more than happy to answer. And again, if you're interested in the other stuff I do, then my private GitHub's open. Container SSH has its own organization now and a wonderful website. Yeah, that's basically it.
Cool. Pretty amazing demo. Thanks so much. You really rushed us through the whole setup and demo. My personal question would be, how long did it take you to build this? It was for me. It was we see really a lot of different building blocks and all the different parts. You have to be like profound in it. So how long did it take to build this?
So I did not start with this setup. That's the preface. So I did use Prometheus for quite a while and Grafana as well. I don't think that you can follow the instructions, and I had a few people test it. I had well, as I said, I worked for Exascale, and one of the new colleagues who joined straight out of the FH Technicum based on the instructions, needed about 2 days to automate this using Terraform. So I don't think that it's an impossible thing to build. The hard part about Prometheus becomes when you want to put it into production, because you actually need to make it redundant. You need to make sure that the database is backed up properly, and then you can restore it. I did have a single Prometheus node setup, which was continuously backed up to an object storage. And then the Terraform script, when it re-provisioned the server, it just downloaded the data from the object storage. That's also a possibility, but it does require a significant amount of engineering. So that's actually one of my main misgivings with the direction that we are currently heading into in terms of cloud native. That there are too many tools. There are these best practices that, yes, you should have everything redundant. You should have Kubernetes and whatever else tool set on top of it. But this all requires orchestration. You can't just go there and then clicky install a Kubernetes and then expect everything to work, because 9 months into Kubernetes, you will face a version change, and then you need to change your manifests, and even if it's a managed service. So that's why I sometimes would argue that in some cases it is better to stick with what you know. And if you really need auto scaling, and I'm seriously saying need here, then look into these things. We had over 1,000 Docker containers, Docker containers in my job about 2 years ago running, where we needed this behavior. So it's not something that you would install for 4 or 5 machines, because the amount of effort you have to put in to make something like this happen outweighs the benefits that you have from auto scaling. And things can break, so you have to realize that this is not something that you can just leave unattended and be happy with it. The main benefit of building such a project is that you really, really get to understand how Prometheus works, the service discovery, how you can drive auto scaling, building webhooks, etc. So I think this is a good learning project. And if you're really hosting, 2-3 racks of servers, then it might also be worth considering potentially starting and shutting down servers based on some sort of a scaling metric to conserve power, because that's when it starts to be economically viable.
But that would also mean in some parts to re-architecture your applications, that everything has to be stateless. If you're shutting, like creating and shutting down servers on demand in a Kubernetes world, most often it's one of those best practices that you should design your microservices to be stateless, so you can easily or more easily scale them. That you have it's just the replica set that defines how many pods are running. That's a little bit more tricky, I assume, when you were talking really about VMs, because a VM is usually a bigger set.
It depends. It depends, because you can get a VM. So you can get a VM with half a gig of RAM or a gig of RAM, and those are fairly cheap. So they cost 5 to 10 euros a month. That's not really expensive. But yes, preserving state is hard. And when you go for and again, you could do auto-scaling of the VMs under a Kubernetes cluster as well. That's what the cluster autoscaler does too. The problem of preserving state is hard, because there are the big three cloud providers, or let's just say big four, together with IBM. They provide block storage. DigitalOcean provides block storage. Everyone else is kind of in the beginning, and this is because block storage is hard. So the block storage part is basically the disk that is not attached to the physical hardware under it. And building such a system is difficult because, for example, DigitalOcean uses Ceph, I believe, and they did have some issues, capacity issues, and I believe also some other issues with it. It's hard because it's very hard to predict the actual load that's hitting your storage servers that are providing the service. So no matter what you do, storage and persistence is hard. If you use it from your cloud provider, then it of course becomes easier, unless you run into issues like we did 2 years ago when you're running out of bandwidth. So when you're starting to hit certain invisible bandwidth limits and things like that. And that's why microservices are better kept small, because then you can launch more servers instead of using bigger servers with bigger amounts of traffic. But these are all hard problems to solve. So that's why my previous question was also about at what point does it make sense to go for microservices, because yes, in the beginning it might look fancy, it might work, but when you actually, the application, when it survives day one, then suddenly the real scaling problems start to hit there, and those are the ones that you didn't think of, because the scaling problems you think of are not problems. The ones that you didn't think of are the ones that are going to come and haunt you, and you might need to re-architecture your whole application anyway. So I don't think that this is something that you would do on day one.
Yeah. Cool. Are there any more questions coming in? If so, please let us know either on Discord or on the YouTube chat. We know YouTube we have a little bit of lag between our StreamYard and YouTube, so we give it a couple of minutes or a couple of seconds. So the lag should not be minutes. Pretty sure they also have their auto scaling, so if more people are joining,
I don't think they have capacity. So that's the thing. If you, I recommend so Google has published a couple of books on how they do things. I don't think they do auto scaling quite the same way that we demonstrated here.
Yeah, but so it would be cool if you can let us know about your the source code that you present, or the project that you presented today. If you can let us know in December how the source code looks like. Maybe someone from the Linz Cloud Native community will give it a try and implement what you just showed us today. It would be really cool to have a comparison. And
I will post the links in Discord, so to the materials that are relevant to the talk, so the original blog post, the lecture site, and once it's done in December, I will post it in Discord as well.
Cool, thank you so much. Perfect. Yeah, I think then for today we wrap it up. Thanks.
Sorry, Jürgen, I have a question. János,
Please.
so you configure to scale after a couple of minutes to avoid
Yes.
false positives, right?
Yes, that is correct.
Did you configure that, or that's something that is automatic or something like that?
So let me actually, I might hop back to Grafana. 1 second, let me share my screen and I will show you what's going on.
Mm-hmm.
I think someone needs to enable my screen share.
Yeah.
Okay. I think we're going back into Inception mode. Oh, here we go.
There we go. So the way that it's configured, if I go into this and edit, the way that this is configured is in the alert tab, and you have the evaluate every 1 minute for 1 minute. So when to evaluate, and then you have here query the last 1 minute, and it's above 80%. So the whole evaluation part is everything is tunable. The defaults are, I think, to 5 minutes. Is above 0.8. Whoopsies. So the default is to for 5 minutes, and I just scaled that down to 1 minute. And this is of course automated. And the way that works is you can set up basically what this does. This whole dashboard here is when I click save, it doesn't let me save because it's pre-provisioned. But this is a JSON file, and if this JSON file you can provide to Grafana on startup. And in this JSON file, if I can really quickly find this, here we go, for 1 minute, frequency 1 minute. So you can set this in the JSON file, actually. Mm-hmm. So you could even make it configurable from Terraform.
Ah, cool. Awesome. Yeah, well, for one service, I think it's fine. But then whenever you have multiple services to manage, I think that's a responsibility for a whole team, right? So you actually have to have your monitoring team managing that and configuring.
Yeah. So again, that depends on my general recommendation in terms of writing an application and doing this is think of what kind of teams you have. If you have one team, then focus on the business perspective. So don't start orchestrating your own auto scaling unless you really need to, because you want to focus on the thing that's making you money in terms of business, and not on building some fancy tools in Grafana. Again, there are countless providers out there. Datadog, cloud providers have some built-in ones, etc., etc. You don't necessarily need to reinvent the wheel. When you hit a certain scale, or when you think that it's technologically or financially untenable to use some other services, then you can think of, okay, I'm gonna use these tools. And it's also important because it's not enough to install Grafana once. You need to. One of the reasons why I automated it is because you can't just install a software and then expect it to work and be secure until the end of time. The more tools, the more moving parts you have, the more things can break, and you need to run security updates. You need to have some sort of a mechanism for that, and it can become real tedious if you have too many parts in your system. And sometimes just installing a plain old VM can be the solution. At other times, you're just going to go for a cloud provider and make sure that you have that documented and automated, instead of just clicking it together. And that will also make it easier, because then in your code, your Terraform or Ansible or whatever code documents how your service is set up. And then, the next person who is going to take that job over from you when you start hating it is not going to hate your guts. It's just going to be a tedium, but it's also, it makes life so much easier, but it requires an upfront investment in building things. And it also requires that your applications are actually, as Jürgen said, stateless. Otherwise, it's going to be really hard to delete and reprovision servers.
Cool. Thanks.
Cool.
All right.
Thanks so much for your presentation. Also, again, thanks to Denis. He already left. He had to jump to another CNCF webinar he had to do at the same time. Thanks, János, again for joining us today. Thanks also to the sponsor, to the streaming sponsor, Dynatrace, for making this streaming possible. We will have another Cloud Native Computing web meetup in November. We will announce date and speakers soon. Follow us on Twitter, subscribe at our YouTube channel. That would help us to get a custom URL. Right now, it's a very tricky URL, not very easy to remember, with a lot of characters and numbers. So if you subscribe to our channel, that would be cool. So we reach 100 subscribers, and then we get a custom URL. Then I think that's it. That's a wrap. And thanks, everyone, and see you all in November.
Thanks, János. Thanks, Jürgen.
Bye.
See you all.